Now understand the next algorithm, which is like boosting. Okay, because boosting is like I would say a lot of machine learning practitioners are these days are actually using the boosting because this is the most powerful algorithm and it is actually used for both classification as well as regression. So just give you a little glimpse about whatever we have discussed before as an ensembling technique. Till now you have discussed about the random forest and using the bagging, right? Bagging is basically a very parallelized approach where at the very end you are actually using the maximum majority voting, and on suppose and on the basis of that you are actually getting the prediction, okay, that whichever tree or for like whichever tree in the random forest is actually predicting the more number of classes. So the prediction model is going to take that as a predicted outcome, right? Now boosting works in a different manner. So boosting is basically work in a very sequential fashion. So let's say that if you have any base model, forget about whether it is a classification or regression, that does not matter. If your base model okay, and it is like intent to do some kind of a prediction, okay, so definitely at the very first stage it is going to give you some error, right? Now what does boosting will do is that it will try to boost your base model and update some part of it, okay, and then it will going to make the another model with the updated weight. Now when I say that what is the updated weight, it does not mean that it is completely going to change the tree, or it does not mean that it is completely going to change the algorithm that I'm supposed to use. So let's say that my base model is actually using the decision tree algorithm, okay, and I have a decision tree root because in decision tree I need to have some root, right? And that base model is actually giving some wrong class, some wrong prediction, some wrong classification. So what I'm supposed to do, okay, so on the same model I will be using some kind of a boosting weight updation, okay, in a way so that the next model that it will going to predict, okay, the next model it is going to predict, that prediction is somewhere the margin of error of the next updated model, okay, is actually low, okay, and because it also contain error, right? Then again we boost the second model, and then we make the update something, we try to update something, and then we will get the third model, okay, and similarly we will process the boosting model until it comes at the very early stop, okay. So early stopping is basically a process where it basically led your model to not overfit, okay, that is why you basically do the early stopping, right? So what is boosting? So boosting is some kind of a ensembling technique. Again, just understand the glossary, just understand the concept, okay, because this is very like in-depth topic, right? So I'm assuming that you already know machine learning before, okay, so that you could able to understand it and in a very freshly manner, okay. So I'm just refreshing your topics, right? So again, boosting is basically your ensembling technique, okay, where it has many weak model. Now when I say weak model, what the weak model means, weak model is basically known as a stump, okay, the stump of the tree. So let's say the tree which is having, let's say, a root node which is having only one signal, like one children, right? So it is directly connected to your leaf node, okay. So this tree is actually having the length as one, okay. So this is called stump one, right? This is stump two, this is stump three. So similarly, let's say you have a 20 stump, which means that you have a 20 weak learner, correct? Now let's understand. So why it is called boosting, okay, because you have some base model. So let's say that you have a training set, correct? Now with your training set you are going to take some subset of it, you train your model, okay, you train your model and you get the model and you get some accuracy and get the error, okay. Now whatever error that you are supposed to get, right, now what you will do with that error, okay, you are going to make the another subset, okay, because let's say that you actually train your model on the weak learner or your stump and you are actually getting the prediction, okay. Now for whichever data you are getting the false prediction, right, so the next model that you are training, right, so before training the next model, the data that you are supposed to use, okay, you are supposed to use that data which you got the error before, so which you are getting as a false prediction, okay, you are supposed to use that data which you are getting as a false prediction, because the correctly predicted data you are not supposed to use it again and again, okay. You try to improve the model accuracy by boosting it, okay. And how will you actually boost it? By actually giving the data which have which has actually given you a very false prediction, okay. It is something like this. So let's say that you are a teacher in a class, okay, and you have a 50 students in your under you, right? Now let's say that out of 50 students, let's say that some of the students are having a very less margin of error in the examination, so you won't give much attention to that student. Okay, your task as a teacher is that you will give the attention to those students which has the very margin of error a little higher. Okay, which is like, which you might think that he or she might fail. Okay, if you cannot guide them. Okay, so you are actually neglecting all those front bencher or so-called topper student, and you will go and assist all those students who actually need your assistant. Okay, so in a way you are actually boosting. Okay, you are actually boosting the entire strength of the class, right, by looking explicitly looking to the weak learner. Okay, so that in this way you can actually like improve the strength, or the result strength of the class. The same way the boosting will work. Okay, so again let's come to the topic. So it has a tree stump. Okay, then you try to update the sample weight. Okay, and then you try to make the another stump. So this is your weak learner 1 with the model 1, this is your model 2, this is your model 3, and then finally you come after some iteration, you try to like get the final model which you think that it is giving you a very good result, right? So again it is your base model, then you actually update your model, you update your model till early stop, right, till early stop. Okay, and then you come to the conclusion as your final model. Now some misunderstanding which I really wanted to like make you understand. Okay, so please understand this part. So boosting creates a multiple strain stumps at the beginning. The answer is no. Boosting will not create a multiple stump as a beginning. Okay, you will take one model as your base model. Okay, one model as your base model, and this is your weak learner. Okay, and you try to boost your base model. Okay, and then you try to boost your base model, and then this is your base model. Let's say 1, and then this is your base model 2. Okay, this is your weak learner 2. Okay, then again you try to boost it, right, to base model 3, and then with the updated weight 3. Another question, just understood that whatever base model you are using, the algorithm that you are using, are you supposed to change the algorithm? No, you are not supposed to change the algorithm. Initially, suppose if you have already chosen the decision tree, then you are supposed to choose the decision tree entire. So it's not working as a heterogeneous. You cannot outmix the model right in the middle of it. Once you've already chosen the model, then you try to boost it, right, by updating the weight. Okay, this is the first part. The second misunderstanding is that all stum are trained randomly first, then we update the weight. No, right, the weight are updated after every stump, not after creating many stump together. Okay, at every stump you are actually creating the weight, not after like once you have bundle of stump then you update the weight. No, it is actually a sequential process. Just understood this. Then boosting checks how many stumps are misclassified in a sample. It is basically incorrect because boosting does not check the group of stump. It only check the current stump, right? That is why it is actually sequential fashion. That until and unless if I improve the current stump, I will not move to the next stump, right? Then again, boosting trained separate independent tree. It's not. It's a sequential process. Boosting uses a different type of model. Heterogeneous? No. Suppose if you're already using the decision tree, then you're supposed to use the decision tree as well till the early stopping, right? Then boosting basically increases the weight if most stump misclassify a point. No. Understood this. Boosting only care about the current stump mistake. Again, right? Then again, boosting randomly decides the root feature. No. Okay, so yeah, so it will not going to randomly decide you a root feature. Then again, boosting gives same weight to all the stump. No, it's not. The weight is getting updated based on the whatever the prediction that you're using. Okay, suppose you're getting the very bad prediction, then you try to increase that weight. Okay, so again, just understood this part. Yeah, this part like parallel tree. So in bagging, there is a difference, right? In bagging, you're actually using the parallel tree. In boosting, you're actually using the sequential tree, right? In bagging, there is a random sampling. In boosting is a weighted sampling. In bagging, you basically reduce the variance. Variance, understand what is variance? Variance is basically the distance from your mean, right? If your mean is actually 0, so variance is basically like how much data is towards the mean, okay, and how much data is like separated by the mean, right? It basically reduces bias. So bagging is basically the base algorithm of like bagging is that random forest, right? When it comes to boosting, it has two way. It has ADA boosting and XG boosting. Okay, now what does this have, right? But before that, just understood this. As I already told you before, that how long should we boost it? Okay, will it not overfit? Because suppose if someone come and tell that just boost your base model till it reaches 50 or 70 state. Okay, it will not work like that. Okay, you will do the early stopping. What is early stopping? Again, this is the keyword. Understood that? Okay. Early stopping is when your training error is low and your validation error is high. Okay. That is the point that you should basically stop. Otherwise, the model is basically overfit. Then again, limit the number of weak learner. That how many weak learner you are supposed to limit. Okay, you need to just limit the number of weak learner in the. I'll show you in the code that that how many weak learner that you're supposed to use. Okay, so weak learner is basically a kind of your hyperparameter, correct? Because these things are already you are actually defining it before the training, right? Then again, you should use the adaptive boosting when, let's say, you have a 550 to 200 learner. Okay, so suppose if you're actually taking the 50 to 200 learner, weak learner or the stump, then you are basically use the adaptive boost. And suppose if you have a good compute, right, so you should use like, and suppose if your weak learner is 100 to lying between 100 to 600, then you should use XZ boosting or light gradient boosting method. Okay, so more tree is not always better. I just understood it, because as a very initial part of your machine learning career, if you think that if I increase the number of tree, it will also increase my accuracy, it will not increase your accuracy. It depends upon that how much precisely you have boosted. Okay, and how much how much precisely you actually take control of the weak learner, okay, the weak student. So that will going to increase the efficiency of the class. Okay, that will going to increase the efficiency of your result as a teacher. The same thing will happen in this way, right? So yeah, so what is basically weak learners? Weak learner, which means that if your depth of the tree. So for now, consider that I am actually using the boosting algorithm for a decision tree. Okay, you can actually use the boosting algorithm for other purpose as well, right? So now, when not to use adaptive boost, whenever you have a noisy label, okay, whenever you have a mini outliers, whenever you have a multi-class problem, you should not use the adaptive boosting technique, right? And then whenever you have a large data set with the high dimensionality, you should not use the adaptive boosting, correct? Then let's understood this part. What is actually gradient boosting, right? Gradient boosting is so again boosting. How many type it has? It has actually your adaptive boosting. Your actually it has gradient boosting, right? Or the light gradient boosting method, right? So when you should use the gradient boosting, when your problem is basically complex, right? When I say that your problem is complex, which means that it has more number of stump. It has, let's say, the stump lying between, or the weak learner lying between 200 to 600. Just understood this way. You are actually again in a you are actually a teacher of a class. Okay, you handle, let's say, 50 student, right? So out of that 50 student, let's say only 10 to 5 student is basically a weak. Then you will go with the adaptive boosting, right? Now suppose that out of 50 student, more than 50% of student is already weak. Then the margin is very high, right? Then you should use and go for some best boosting method, right? So you should basically go for some gradient boosting, right? So it is basically uses the approach of gradient and other things, right? So the mathematics part I will cover it later, because it is just a ML foundational course, that's why. Right, whenever you have a high dimensional data, you are actually dealing with the real life business data set, then you should, then you, whenever you have a very complex relationship between the feature, then you should use the gradient boosting. So till now I'm guessing that you have understood about what is boosting, what is a sequential fashion of training a model. Okay, what is early stopping, what is the type of boosting, gradient boosting, adaptive boosting, when should you use as a machine learning practitioner as a adaptive boosting, and when should you use the gradient boosting. Okay, I hope you clear it. Now, what is the scenario? Again, this is actually the adaptive boosting, gradient boosting. Data cleanliness, best for cleaning data, best for noisy data. Complexities, if your pattern is very simple, go for adaptive boosting. Otherwise, go for gradient boosting. Let's say if you have a non-linear pattern, right? Then training, again, this is actually faster, right? Because you have a very less weak learner in adaptive boosting. It is basically slower. But if you have a good compute, go for gradient boosting, right? Then again, overfitting, less pruning. Now what is basically pruning? Pruning, I have already told you in the decision tree, right? Pruning is basically process, right, of filtering out or draining all those unnecessary leaves, which is creating the complexity issue, right? Then when it comes to loss function, it is basically exponential loss. It is like any meter differentiable loss, right? Then task, mostly binary. And if you have a regression problem, binary problem, multi-class problem, go with gradient boosting. So adaptive boosting is basically whenever you have a let's say mostly binary set of a problem. Okay, you should actually go for adaptive boosting. Model stability, unstable with outlier, and then more stable. So till now, whatever we have understood, we basically figure it out that if we have a good compute, we should definitely go for a gradient boosting, right? So these are the little glimpse of the boosting. I hope you understood. Okay. Just let me know if you have any issue in the comment section, so I'll definitely revert it back.